Quick instructional video here to introduce the concept and the term net force. Net force is the sum of all forces acting on an object. Symbols for net force are Greek letters sigma with an F for sum of the forces, or an F with subscript net for net force. The Greek letter sigma looks like that, and in math and science it is used to stand for the phrase sum of. Initially we will restrict summing the forces either along a horizontal dimension or vertical dimension. So we'll refer to sigma fx, which is the sum of the forces that are horizontal, or sigma fy, the sum of the forces vertical. Here's a worksheet that you'll be doing, and on the top is an example. The job is to identify the magnitude and direction of the horizontal and vertical net forces. So the object is square, and it shows force 1 and force 2, and the magnitudes, 7 newtons and 2.5 newtons to the right in this case. So we add horizontal forces separately from vertical forces. So here's the sum of the forces x horizontal. It's both of these forces that are shown, 2.5 plus 7 newtons, is 9.5 newtons to the right. And there are no vertical forces, so the sum of the forces in y are 0. So that means overall the net force is whatever that is right there. So if there's a net force that's not equal to 0, that means the forces are unbalanced. So we'll circle that. And if there's unbalanced forces, do the velocities change? The answer is yes. Here's another example with forces acting both vertically and horizontally. To the right will be considered positive force, and up will be considered a positive force. Any force to the left is negative, or down is negative. So we have to sum up the forces horizontally, which would be sigma fx equals 2 newtons plus that 2 newtons to the left is going to be a minus 2 newtons. Remember, sigma means sum of, so we're adding, but we add a positive to a negative, and that is 0 newtons for the horizontal forces. And the vertical forces, we have 5 newtons up plus the 5 newtons down, which also equals 0 newtons. So therefore, overall, the sum of the forces on this object equals 0 newtons. Since the sum of the forces is 0, that means the forces are balanced, and delta velocity, change in velocity, will be 0, meaning the velocity will stay the same.